Hello everyone, it's Suspensions Guy. Please follow us on Instagram at the rate Suspensions Guy and do read our blog post on suspensonsguy.wordpress.com. Make sure to hit that like and subscribe button so you'll get the latest notifications and updates from our channel. So today we are going to talk about Antisquat suspension geometry. This is the second part of my video from Antisquat and anti-dive suspension geometry. Anti-dive I have already discussed in my previous video. So starting with a quick recap on what is anti-geometry. Anti-geometry are classified into anti-dive and anti-squat refers to the design of suspension setup which alters the response of its component during braking and acceleration. Basically, it affects the pitch moment of the car as the car dives or squats. Here is a quick representation of how the car squats during the acceleration. So, today we are going to discuss about what is anti-squat geometry and how to draw and calculate anti-squat, what are the advantages and disadvantages, and most importantly, what is 100% anti-squat and how does it affect our design. So starting with what is anti-squat geometry. When the car accelerates, it tends to lift from the front and dives from the rear, causing the load transfer from the front towards the rear through the center of gravity point. To oppose this action, anti-squat geometry is implemented in the design such that the forces will travel through the suspension arms and the springs collectively. Here we need to understand that it does not change the wheel loads on the front and the rear, it only affects the weight transfer during braking to be distributed between suspension arms and the springs. Now we will be seeing how to draw and calculate anti-squat. For the first step, draw a tire representation in the side view and locate the center of gravity height and its distance from the front tire. Now, for the step 2, draw lines from the mounting points, that is the upper and the lower wishbone, towards the front of the car. Next, draw another line extending from the bottom of the tire contact patch passing through the connecting points of lines of step 1. The point connecting all the three lines forms the instantaneous center, whose distance is shown by the SVSA length from the center of the rear tire. Now for the step 3, the distance from the center of tire to the point of instantaneous center is called as the SVSA length, that is the side view swing arm length. Step 4, the height of the instantaneous center is called as the SVSA height. For step 5, the point O at which the line extending from the instantaneous center connects on center of gravity line represented by height h determines the anti-squat percentage. Now here are some quick formulas which you will be requiring for calculating the anti-squat percentage of your design of the car. So here is a quick representation of the anti-squat and the formulas you will be requiring for the calculation. Now we'll be discussing what is 100% anti-squat and how it will be affecting our design. Here, when the line extending from the bottom of the rear tire towards the front and connecting instantaneous center cuts the center of gravity point of the vehicle, then the vehicle is said to have 100% anti-squat. The anti-squat percentage refers to the compression, that is, of the suspension during the braking. 100% refers to the stiffness will be increasing and the suspension setup will neither compress or extend during the diving or the squatting, and majority of the forces will be taken by suspension arms. The effect of the forces will increase as the percentage reduces. You can read our blog post on https at suspensonsguy.wordpress.com and follow us on Instagram at the rate suspensonsguy. Make sure to hit that subscribe button to get the notification and updates of our videos on amazing topics of design on Formula cars. If you have any queries or questions on, you can put that in the comment sections below. And thanks for watching.